All right, folks, Mr. Bucko here with solving quadratic equations. And we're going to solve quadratic equations graphically, and then we'll do it algebraically. These quadratic equations, however, will all be in vertex form. So we did solve quadratic equations earlier with quadratic formula and factoring. Now we're going to solve quadratic equations that are in vertex form, which will make graphing them a lot nicer and easier. And then there's kind of a short algebraic way to do that too. So we'll see both of those right here. So to solve a quadratic equation graphically, we're going to take the single equation and separate it into two equations, kind of like we did with absolute value. And then we're going to graph those two equations and find the intersection. And where they intersect is where the solutions are. So we have the quadratic equation 2 times quantity x minus 3 squared minus 7 equals 1. Notice that this left-hand side is a quadratic, and it is in vertex form, a parenthesis x minus h parenthesis squared minus k, or plus k, in this case it's negative 7. This equals 1. So we're going to split those into two equations. So again, quadratic equation in vertex form, we know how to graph that. The vertex of this parabola is 3, because it's the opposite of what's inside the parentheses, and then negative 7. Then we can plot points or pick points on each side of the vertex and plug them into the equation and see what we get out for the value of the function, or the y value, and then we'll plot those points. Then we'll graph g of x equals 1, the right-hand side, and when we do that, we get this graph here. So notice our vertex is right down here, the vertex right there, 3, negative 7, as we can see in the vertex form. We can plot or plug in 4, and if you plug in 4 into this function, it looks like you get out negative 5. You can plug in 5, and it looks like you get out 1, and then you can reflect those points, and then graph the line g of x equals 1 right here, and we can see that these two graphs intersect at 1, 1, and 5, 1, which means the solution to this quadratic equation is x equals 1 and x equals 5. So when x is 1, this equation is equal to 1. When x is 5, this equation is equal to 1. So that's what this looks like graphically. To solve it algebraically, which is usually a more precise and less tedious task, we're going to isolate the squared expression. So kind of like we did again with absolute value, we isolated the absolute value expression. Now we're going to isolate the squared expression and then decide whether the equation can be solved, because we're going to keep in mind that squares can't be negative. So when we square something, it always comes out as a positive. So that's what this sentence is saying. And then write as two separate equations based on whatever that is. So what does that mean? If we have negative quantity x plus 1 squared plus 3 equals negative 13, we're going to isolate the squared expression. So I'm going to subtract 3 on both sides. Gives us negative 16 on the right-hand side. Plus 3 is gone. Then we're going to divide by negative 1 to get rid of the negative there. So we get x plus 1 quantity squared is equal to 16. So now we ask ourselves, well, what squared is 16? What number needs to be inside this parenthesis so that it's squared and equals 16? Well, that's going to be negative 4 and positive 4. So x plus 1 can be equal to positive 4 because positive 4 squared is 16. Or x plus 1 could be equal to negative 4 because negative 4 squared is positive 16 also. Let me solve these two basic algebraic equations. X plus 1 equals 4. That's got to be 5. I'm sorry, 3. 3 because we subtract 1 on both sides. And x plus 1 equals negative 4 is going to be negative 5 because negative 4 minus the 1 is negative 5. So 3 and negative 5 are the solutions to this quadratic equation. When we plug in 3, this side will equal negative 13. When we plug in negative 5 right here, this whole thing will simplify to negative 13, and we have our solutions. Do one more, or maybe two. 3 times a quantity x plus 4 squared plus 5 equals 2, so we want to isolate the squared portion, or the squared expression inside the parentheses here. So subtract 5 on both sides. Negative 3 on the right-hand side. Then we're going to divide by 3. Divide by this 3 here on both sides, get rid of that 3. And we get the quantity x plus 4 squared is equal to negative 1. So we have to think, well, what does x plus 4 need to be? What squared is negative 1? Well, Nothing. A quadratic cannot equal a negative value. No matter what number goes in here, whether it's positive, negative, doesn't matter. Once you square it, it will always come out as a positive. So there's no solution because of this. Nothing squared will ever be a negative number. So no solution. Now we'll do one more. 1/3 times the quantity x minus 4 squared plus 1 equals 4. Isolate the squared expression. So we'll get that x minus 4 squared all by itself. We'll do that by subtracting 1 on both sides. We have our 3. Then we're going to divide by 1/3 or multiply by 3 here on both sides to get rid of this 1/3. We do that, we get x minus 4 quantity squared is equal to 9. Now we have the squared expression all by itself. What squared is 9? That would be 3, because 3 squared is 9. Or it could be -3. -3 squared is also 9. So x minus 4 could be 3, or x minus 4 could be -3. Solving each of those, we get 7. 7 minus 4 is 3. Or x could be 1, because 1 minus 4 is -3. So the solution, or the solutions to this quadratic equation are 7 and 1. What does that look like on a graph? It would look like this. So we have this equation right here. The vertex is 4, 1. So we can see that right here. We can plot points on each side. So you can plug in a 5, you can plug in 6, you can plug in 7. Then you graph this line, which is y equals 4. And we can see that these two parabola, the parabola and the line, intersect at 1, 4 and 7, 4. That means that both of these are equal to 4 at the points where x is 1 and x is 7. And that's how we solve quadratic equations that are in vertex form, graphically and algebraically.